In this problem, we're being asked to do a bunch of operations with the functions f and g. In part A, we're being asked to find f of 3 minus g of 4. So for this problem, we have to do two things first. We need to evaluate the function f when x is equal to 3. So to do that, I'll copy down the shape of my function f, but I'll replace the x with an open parentheses, and then I will substitute the value of x into that. I'll put in a 3. So that chunk of stuff is going to work out to be f of 3. And then from that, I'm going to subtract whatever g of 4 is. To find g of 4, I'm going to do the same thing. I'll copy down the shape of g. The value of x gets increased by 3. And then I will plug in the value of x. It's equal to 4. Once I'm here, I just need to follow the order of operations. Inside the left parentheses, I'll do the exponent first. 3 to the second power is equal to 9. 2 times 9 is 18, and 18 plus 1 is 19. The right-hand side, 4 plus 3 is 7. And then 19 minus 7 is 12. For part B, I'm asked to find a combination of functions. I want to find f over g of x. That's the same as just having f of x over g of x. And to find a combination, you just basically plug in the formulas for f and the formula for g. So in the numerator, I know that f of x is 2x squared plus 1. G of x is x plus 3, and I should try and reduce that if I can. There aren't going to be any common factors, so that is f over g. To find the domain of that, what I need to do is look at the domain of f. The domain of f is going to be the set of real numbers because it's a polynomial. There's no value of x that I can't put in that won't give back another number. The same is going to be true for g. The domain of g is also the set of real numbers. So there's no value of x that I can find in the entire universe that I can't put into the numerator and put into the denominator. There's no problem there yet. The problem is when you have a quotient, the denominator cannot be 0. So the denominator in this case is x plus 3. This cannot be equal to 0, so x cannot be equal to negative 3. So x cannot be negative 3. And if I wanted to, I could state that in integral notation. I would go all the way from negative infinity to negative 3, or from negative 3 to infinity. And as long as I'm in one of those two intervals, I'm okay. So I would use or. That's the union u. For part C, I want to find, instead of a combination, I want to find the composition. F of g of x. And some people like to think of this, instead of f of g of x written this way, you're taking f of x, and you will plug into it g of x. And thinking of it that way makes it a little bit easier to see how to write this out. So just like I did in part B, I'm going to start with the shape of f. F is 2 times whatever x is squared plus 1. And then I will put into it whatever g of x is. G of x is x plus 3. And then if I perform my algebra on this, I will end up with 2 squaring x plus 3. I'll get x squared plus 6x plus 9. Distributing the 2, I'll get 2x squared plus 12x, and then 2 times 9 is 18, plus 1 will be 19. Finally, for part D, I'm asked to find for what value of x does g of x equal negative 4. Well, I know that g of x is equal to x plus 3. So x plus 3 is negative 4. If I solve this for x by subtracting 3 from both sides, I'll get x is negative 7.